In this video, we're going to look at how to reduce an alcohol. Let's jump right in. We remember that reductions are those reactions where we make fewer carbon-oxygen bonds. So if we're going to reduce an alcohol, which starts with one carbon-oxygen bond, we need to turn it into 0 carbon-oxygen bonds. So we need to replace the OH with a hydrogen. Now, in previous reductions of carbonyl compounds, we use reagents like lithium aluminum hydride or sodium borohydride, but those aren't going to work for our cases this time because the OH group is not a very good leaving group. So here's how this works. The first thing we need to do is turn the OH into a good leaving group, and typically in this reduction, they use tosyl chloride and pyridine to turn the OH into a tosylate group, a tosyl group, which is a good leaving group. Then we add a good reducing agent like our LAH. That can be written LAH or lithium aluminum hydride. Those are the same thing. And the LAH is a source of hydride. That hydride replaces the OTS and makes our reduced compound, replaces the OH with a hydrogen. So we turn the OH into a tosyl group with tosyl chloride and pyridine. Then use the hydride, go ahead and grab the strong one, LAH, and replace the OTS with a hydride. And that's how you reduce an alcohol with one carbon-oxygen bond to an alkane with no carbon-oxygen bonds. I hope that helps. Subscribe to the channel so you can watch more of these organic chemistry videos, and click on the next organic chemistry video in the alcohol reaction chapter.